Hey grade 9, so we are just going to be moving on into our next section of the math. And so we're going to be talking about scale diagrams, enlargements, and reductions, just like I have on the paper here. I do apologize that the diagram isn't very nice. I'm just dealing with, I guess, the worksheets and the stuff that I have here at home, so you're going to have to bear with that. So hopefully you can see I've got a map here of Victoria Island. And on the island, there are a couple of different places. There is Cambridge Bay, which you will see right here, and I'm just going to point to that for the moment. And then there is Kagluktuk, which happens to be right about here. And so, as many of you know, if you've used maps, I don't know how many of us use maps too much anymore. I know a lot of us use the maps on our phones and things like that, and they will tell us basically how to get from point A to point B. It already tells us how far each distance is from one point to the next point. However, scale diagrams do play a role in map making, and so I do want to kind of come back to this skill as one that many of us, it's a good skill to learn, not just with maps, but also with any kind of enlargements, reductions, models. There are so many things out there in the world that we are constantly enlarging or reducing or making models of. And so I guess nowadays we might even consider like 3D printing and things like that to be something of use as well. So I'm going to get into this. One thing that we're going to talk about is scale, and so scale factor and things like that. The question does say what is the scale and how is scale used? So I'm going to answer that briefly here and just talk about, we notice that on every map there is some sort of scale. And so in this particular case, if I were to measure one of these little lengths here, it's about 1 centimeter. And I know you can't really see the measurements on this ruler. And like I said, I'm just kind of dealing with the type of ruler that I have. But we've got 1 centimeter. Okay? And so 1 centimeter, according to this, is going to be equal to 100. And the units there is kilometers. So I'm just going to write off to the side here. 1 centimeter is equal to 100 kilometers. Now, rates, when we talk, I'm going to introduce some new terms here. A rate is a comparison of two different units. So when I compare centimeters to kilometers, that would be what is called a rate. Now, if I want to put that as a scale factor or a ratio, I would want things to be in the same units. So if I wanted to convert this 100 kilometers over to centimeters, that goes back to our last unit. So if you haven't watched the video from last week, week 4, please go back and watch that video because it's going to tell you how to convert kilometers to centimeters. So we know that there are 1,000 meters in a kilometer. We also know that there's 100 centimeters in a meter. Or if we even go back to that staircase method, I'll just kind of show you briefly. This was in the last video. We've got 1, 2, 3, 4, 5, 6 steps. So, oh, did I go too far? 1, 2, 3, 4, 5. Sorry. 5 steps that it goes down. So basically, I could think about that as like adding on or multiplying that by 100,000. Or I could think about moving my decimal over 5 places. Okay, so we're just going to change this over to centimeters. Alright. So then I could write that as a ratio. So it's 1 centimeter to, when I multiply that, I get 10 million centimeters. is what the 100 kilometers is equal to. So that would be my scale factor. Okay. Now, how can we can also use the rate when we're trying to convert or change things or to find out like what is the actual distance. So I did measure this ahead of time from one distance to another distance. I measured it out to be 56 millimeters or 5.6 centimeters. So I could actually do a ratio or a proportion. A proportion is what I'm doing here. If I have different units, I want to make that equal to, okay, I know that this is 5.6 centimeters, the distance from this spot to this spot. Okay. What is that in kilometers? So I've basically put my centimeters on the top shelf of my proportion, and I've put kilometers on the bottom shelf of that proportion. And so it's a matter of doing cross multiplication. So I can cross multiply these two values and then divide by that odd man out. Okay? Or some people think about, okay, cross multiply here. 1x is equal to 100 times 5.6. And I got 560. So then 100 times 5.6, 560, that is my kilometers. Now, had this not been a 1 and it had been some other number, I would have had to divide it on both sides. Okay? We'll see more of that a little bit later here. So I'm going to move on just to a few other things that I do want to just discuss here. Ooh. And bring this forward. Okay, so scale factor is you're basically taking the length of the scale diagram divided by the length of the original diagram. So that is going to be your formula. Okay. Now, if we happen to have an enlargement, so something that is made bigger, that means if you're making something bigger, you're going to take the larger dimension, because that's going to be the length of the scale diagram, okay, divided by the smaller. So not a bad idea to have these couple formulas down on your page for scale diagrams or scale factor. Okay? And then if we're reducing something, meaning we're taking something large and making it smaller, then the new one is going to have a smaller dimension divided by a larger dimension. So that's for reduction. So, not a bad idea. Put some notes down on a piece of paper. I will try to get these scanned and into the files for you to look at later, but it's handy to have your own little note page there as well. Alright, so moving on to some examples where we can use this and put it into practice. You'll see a lot of this in like sciences, in engineering, in art classes, a variety of different things. I'm just coming up with a couple off the top of my head. Alright, so in this example it says, this drawing of a mosquito was printed in a newspaper article about the West Nile virus. The actual length of the mosquito in real life is 12 millimeters, so that's about 1.2 centimeters, a little bit bigger than a pinky thumb, or pinky, right? And so what I have here, looking at it, if I determine the scale factors, what we're trying to do, so I'm going to measure in I'm going to measure in millimeters, because that is what they gave me the original in, and I do want things to be in the same units when I do divide them for scale factor. So in this case, you probably can't see that. I apologize. I don't know if I have a better ruler. I am going to take a quick. These are all rulers that my daughter had when she was in school. Not sure if you can see that any better, but we've got 1, 2, 3, 4, a little more than 5 centimeters. So when we do millimeters, that's 10, 20, 30, 40, 50. There's about 52 millimeters. So we're just going to label that 52 millimeters. Okay, and now because this is an enlargement, we made it larger. We're just going to take scale factor for an enlargement is equal to the larger value divided by a smaller value. So we're going to go scale factor is equal to the 52 divided by 12. Those were both in millimeters, which is important. As I mentioned, you want them to be in the same units when you are going ahead and dividing that. Now if I divide that, I've got about 4 1/3. Okay, or you could write that as 4.3. Okay, or 4.3 repeating. So that is the scale factor. So it's multiplied, the original mosquito was multiplied by a factor of 4.3. Okay, so you could then take his wing and take the dimension of that and then multiply by 4.3 to get how big the wing should actually be. That's how it's used. Alright, gonna go into what do we do when we are trying to find the new dimensions of something. So if we're enlarging something, how do we go about finding new dimensions if you're given the scale factor, which we are here. So it says this particular picture of longhouses has a dimension of 9 centimeters by 6 centimeters. And if I want to enlarge the photo by a scale factor of 7/2, or you could also think of that as 3.5, calculate the dimensions of the enlargement. So we would go 9 centimeters times 7/2. If you want, like I said, change that to a decimal. Or just multiply by 7, then divide by 2. Okay? And you get 31.5 centimeters. Now we're going to take the other dimension separately. And you get 21 centimeters. So the enlargement will have the dimensions (31.5 centimeters by 21 centimeters. Okay, so that is how we go about with that one. And one last part that I do want to show you today is how do we decide if two things are proportionate to each other? Get that all onto the screen. So what does it mean to be proportion? It means that two ratios are equal to each other. So for example, if we happen to have 3/4, we know that that is equal to 6/8. If I reduce 6/8, dividing it by 2, dividing it by 2, I would get 3/4. So those are both equal. So they are proportionate or proportional. So two diagrams are proportional if all sides are multiplied or divided by the same number. So how we can check that is, for instance, I can see that this is 10, the original is 10 blocks by 5 blocks. Okay, 1, 2, 3, 4, 5. And so if I wanted to convert, I can compare my length of original to the length of the new one. Okay? Scale diagram. So scale factor is the length of a scale diagram to the length of the original. Or we can compare our width of the scale diagram to the width of the original. Or you can even just go okay, 10 to 5, is that going to be the same as this length to this width? So there are a few different ways to look at it. Okay. So let's go ahead and compare. So in A, I can see that in this case my length here is 1, 2, 3, 4, 5. So if I go 5 over 10. Okay, so this is length. So I'm comparing the two lengths, the length of this one to the length of that one. Is it the same as the width, the ratio that I would get from my widths? So that's 1 to 5. Well, no, that doesn't work. 5/10 is not equal to 1/5. Okay, so A is not going to be proportionate to the original. What about with B? Well, my length in this one happens to be 6, and my original was 10. Well, my width of the scale diagram is 2, but my width of the original was 5. So 2 to 5. Well, that doesn't make sense, so no. Those two fractions are not equal. And then lastly, let's just look at C. We have, that is 8 to 10 for my length, so 8 and 10. And then if I take my sides, that's 4 and 5. Well, yes, that works because I know that 8/10, if I divide by 2 and divide by 2, that would be 4/5. So those two fractions are equal to each other. So C is proportionate to the original. Like I said, I could have checked, okay, this is 10 to 5. Okay, that's not the same as 1 to 5. Not the same as 2 to 6. But it is the same as 4 to 8. Okay, so you could have done it that way. It's just a matter of whatever way we were thinking about it. However, it can get tricky later with some things. So shapes with much more sides. Alright, and my last example here is going to be drawing a scale diagram of this shape. They call it an octagon because it does have 8 sides, even though it's not a regular octagon, which a regular octagon would look like a stop sign. But this one does have 8 sides. So, it says draw a scale diagram of this octagon with a scale factor of 0.25. So, if I measure out, I measure that is 7 centimeters. This is about 2.3 centimeters. This inner part is 4.7 centimeters. 2.3 centimeters. 2.3 centimeters. And 7 centimeters again. So I did some calculations previously, and I just went, well, what's 7 times my scale factor? So I do always have to multiply by my scale factor. I should get a much smaller size. which do go to a couple of decimal places here, is 1.75 centimeters. So then I can go ahead and draw something that is about, so this is going to be kind of small and not the most accurate. Go to about 1.8. So it's kind of small there. Okay? And if I do this side, well, that was 7 centimeters as well, so I could actually do that along the back side here. Is going to be 1.75. And again, along the bottom will be as well. Okay, so I got those 3 sides. And then if I take 2.3 and I times it by 0.25, well, that's 0.575. I'm probably going to round that up to about 0.6-ish. And it's going to come off of each section there. And then it's going to jut in 4.7 times 0.25 will equal about 1.175. So about 1.2. And that should be about the 1.6, a little bit more. I feel like I got something a little bit off, but trying to make those all right angles as well, and that would be my reduction. So I'm going to leave this video at that point and give you some assignment work to do from your textbook, and you will see that just underneath this video what your assignment is. Alright, take care.